So you're going to need out your periodic table. I'm Mr. Brosnan, if you haven't met me before. So we got a couple jokes for you. What do you call cheese that's not yours? Pause your video, see if you can come up with the answer. Nacho cheese. Why couldn't the bicycle stand up by itself? Again, pause the video, see if you can come up with the answer. It was too tired. All right, so this is where you're going to need your periodic table out. I want you to find element number 11 over here and element number 17 over here. That's what we're going to be talking about on the next page. So it says here, it was mentioned previously that sodium atoms lose an electron and chlorine atoms gain an electron. So they have the same number of electrons as a noble gas. So if we look here at this diagram, we got sodium over here, and it's got this one lonely electron on the outside, which makes sodium very unstable. We have chlorine over here, and it's got 1, 2, 3, 4, 5, 6, 7 electrons. If you can get 8 electrons in its outermost shell, it'll be very stable. So chlorine really wants to get that extra electron. So what happens is this electron moves over to chlorine and makes chlorine very stable. By losing this electron, it makes sodium very stable. But sodium now becomes sodium ion, and chlorine becomes chlorine ion, which we call chloride. So when you put sodium atoms and chlorine atoms together, they provide a little energy. The sodium atom transfers an electron to the chlorine atom, and the compound sodium chloride is formed. So 11, 11, this is neutral. 17, 17, this is neutral. But when the sodium gives up an electron, it gets a positive 1 charge. When that chlorine takes on an electron, it gets a negative 1 charge. So neutral sodium atoms are chemically reactive, and so are chlorine atoms. Neutral sodium metal explodes in water, and chlorine is a green poisonous gas. So if we look over here, we see toxic gas, chlorine. You need a gas mask if you're around chlorine. Let's watch sodium explode in water. There we go. So what's happening here is the sodium is reacting with the water. Hydrogen gas is produced. That's why it's moving all over the place. It's creating little bubbles of hydrogen gas. The temperature of this reaction is quite high, so the hydrogen gas actually starts on fire. Later in the year, we'll show you this same reaction with big chunks of sodium. So again, it's bouncing around because of the hydrogen gas that's forming. When the neutral sodium atom gives up an electron, it becomes sodium ion. Again, sodium ion is Na1 positive. And it becomes more stable because it loses the outermost electron. When neutral chlorine atom gains an electron, it becomes more stable as well. But it turns into chloride. The two ions are now attracted to each other. This positive's attracted to this negative, and so they're stuck together like two ends of a magnet. Sodium chloride is a very stable compound since the ions that it makes are also very stable. Sodium chloride doesn't explode, doesn't give off light, or do anything neat. That's because it's very stable. The definition of a compound is 2 or more elements chemically combined together. You'll definitely need to know that for the rest of the year. And then it goes on to say it's an indefinite ratio to form a new substance. In other words, the elements in a compound are always found in the same ratio. This means that a sodium chloride will always be 1 sodium with 1 chloride. It'll never be 2 chlorides. Water will always be H2O. If I have H2O2, That's a different compound. That's called hydrogen peroxide. It has different properties than water. So now we're going to look at magnesium, and we're going to look at chlorine. Now, if we look here in this box, chlorine wants to get rid of 2 electrons. That's how it gets a 2 positive charge. Chlorine wants to take on 1 electron to have the same number of electrons as argon over here. So it wants to take on 1 electron, but magnesium wants to get rid of 2. So how does this work? It says if you took the elements magnesium and chlorine and reacted them together, the magnesium atom tends to lose 2 electrons. So magnesium's got this electron out here and this electron out here, making it very stable. They're not held on to very tightly. And if it loses those 2 electrons, then it has 8 electrons in this orbit. And that makes it stable. So we mentioned earlier this week that when electron or an element has only 8 electrons in the outermost shell, that makes it very stable. So since magnesium tends to lose 2 electrons, there must be 2 chlorine atoms to take them on. So here's chlorine. 1, 2, 3, 4, 5, 6, 7 electrons. And the other chlorine's the exact same way. If it can get 8 electrons, it'll be very stable. So the magnesium gives up 1 electron over here. And it gives up 1 electron over here. And if we look now, magnesium's got 8 electrons in its outermost shell. Chloride has 8 electrons in its outermost shell. And this guy has 8 electrons in its outermost shell. So this has got a 2 positive charge and 1 negative, and these negatives are attracted to the positive. And so the molecule sticks together. In a compound, the negative charges must be balanced out by positive charges. In other words, compounds are, if you're not negative and you're not positive, you are neutral. So that means no overall charge. Ionic compounds are made of 2 ions. So ions, positive ions and negative ions. That's what ionic compounds are made out of, when these 2 are attracted to each other. Also, ionic compounds are a metal that want to lose electrons, and nonmetals reacting together. Nonmetals want to take on electrons. Cations are blank ions. I always look at this T right here. The T looks like a plus. So cations are positive ions. What form cations? Well, metals lose electrons. When metals lose electrons, they become positively charged. So metals form cations when they lose electrons and become positively charged. Anions are negative ions. Nonmetals form anions when they gain electrons to become negatively charged. So cations are metal ions and anions are nonmetal ions. So here we go. These are some rules that we're going to use to do our first naming in chemistry. So the first element's a metal with only 1 charge, and the second element is any nonmetal. We're going to write the name of the metal as it is. We're going to write the name of the nonmetal with an "ide" ending, and then we're going to adjust the formula so that the overall charges are balanced. So here we go. We got an example here. Here's calcium. We see a 2 positive in that box. So calcium, Ca2 positive. How did it become 2 positive? It lost 2 negative electrons. Here's oxygen. So write down oxygen. It's got a 2 negative in the box. I go O2 negative. How many electrons does it gain? Well, it's got to gain 1 to be like fluorine and another one to be like neon. So it gained 2 electrons. So there's a correlation between those numbers and between those numbers. I chop off the last part of the name. So oxide is the name. I name the metal just as it is. And then I name my modified nonmetal ion oxide, calcium oxide. This has a 2 negative charge. This has a 2 positive charge, and they balance each other out perfectly. So try the next one. I'll go over it in a second, but try the next one. Pause the video. See how you do on that one. So this is lithium right here. And this is selenium right here. So if I look at lithium, it's got a 1 positive in the box. So Li 1 positive. That 1 positive right there. And then how many electrons does it want to be like a noble gas? If it loses 1 electron, it'll have 2 electrons, just like neutral helium. So it wants to lose 1. And then we just call it lithium ion. And I mentioned before, that's what's in batteries. We go down to selenium. I got to erase a little of this so I can see in the box a little bit better. Selenium's got a 2 minus. So Se2 minus. It needs to gain 1 electron to be like bromine and another electron to be like krypton. So it wants to gain 2 electrons. It gets a 2 negative charge because of it. So again, a correlation, correlation. I knock off the name, end of the name, and I add ide, so selenide. I write the formula, Lise. But there's a 2 negative here and a 1 positive here. Those don't balance each other out. So I'm going to need 2 of these lithiums to get a 2 positive charge and 1 of the seleniums. And I do that by putting a subscript right there. That means I have 2 lithiums and 1 selenium, and that balances out to 0. How do I name it? Metal, lithium, and then selenide. So I want you to try the rest of them. Pause the video, try the rest of them, and then I will scroll through and give you the answers. So there is the first one that we just did. Make sure you absolutely pause the video here. Do the next one. Play the video, see the answer, so forth and so forth. So there's the next one. Check your answers. Pause the video, try the next one. There's the answers. If you're not pausing the video and practicing, you're going to have a very hard time in chemistry. This is the bare bones basics of chemistry, and we use them all year long. Again, make sure you're pausing the video and trying these problems before the answers are revealed. If you can't get this stuff, you're going to have a very hard time in chem. And there's the answers. Now, this year is the year of COVID-19, so what you're going to have to do is we're going to do the 35s as your homework. So the 35s, we already taught you how to do, 35.0. Taught you how to do it. And since it is a COVID year, you're going to send us a picture of that by tomorrow morning. At 8 o'clock, we're going to release the answer key so you can check your answers. But if we don't get a picture by 7:59 in the morning, then it's going to come in as a late assignment for you. In non-COVID years, we'll just correct this in class. So again, I'm Mr. Brazen, and I'll see you later.